Hi everybody, I want to go over covalent bonding practice sheet number 1. Not all of the problems, but some of the more troublesome problems from the homework. Let's start with number 2. Number 1 was a pretty clear-cut problem. In number 2, I had to do H3PO4. Most of you had no problem adding up the valence electrons up correctly. Each H has 1, so that's 3. P has 5. So again, you want your periodic table nearby. Each O has 6. So that's 24, and 24 and 8 make 32. Now it says that the H is bonded to the O. We have to assume that H cannot be our center atom. Just can't be possible. So what we have to do is make P our center atom. So P goes in the middle. We'll do 4 O's. And just keep in mind that all acids will have this sort of configuration, where the O's go around a central atom, and then the H's will bond to the O's. So what happens is the H's are actually, this is still part of the picture, I'm just going to use another color, are bonded to the O's. So that's how it should look. I have to put on all my valence electrons. Everybody needs 8 except for H, so I'm not going to put any dots here on the H, no dots. But I will put 4 dots here on this O, 4 dots on the other O across from it, 4 dots on the bottom. The only O that needs 6 dots is the O that is not attached to an H. Remember, I have 3 H's in the compound. When I add up the valence electrons, I should actually see 32. So you can count these, but it is 32. It is a match. It means this is actually done and correct. And rarely you'll see those double bonds in an acid, not that it couldn't happen. So this is done, and we're going to go on to the next one. So the next one that was problematic, number 3 was pretty basic. Everybody counts 26 valence electrons in PCl3 and should be all single bonds. So let's go to number 4, which is PO3 negative 3. That's a phosphite ion. We have to remember, when we add up our valence electrons, we're going to add 3 to the count, because the minus 3 means gain 3. So let's start counting with the 5 valence electrons per P. Each O is 6, so that makes 18. And another 3. I have a little cold today. So here we go. We do our total count, and our total count should be 26. So we draw our picture, and again, we draw it as if everything is perfect in the world. Everything's going to be a single bond, and we hope that it turned out correct. So we're going to put all of our electrons around the P and around all the O's. Each O is going to need 6 dots to complete the 8. And what we're going to do is also not forget that you always have to put brackets and a charge on anything that has a charge. Otherwise, it would almost be like you were drawing PO3. We're not drawing PO3. So let me just erase that cross out for a second there. There we go. I'm getting the hang of this, guys. Oh, no. Here. Let's do that. There we go. Sorry. So if I count, I should have 26 valence electrons. So this should be actually fine. There's 8 here, 8 here, 8 here. That's 24 plus 2 makes 26. So this is also done. If we go to the next one, SO3, number 5 is SO3. It's really clear that it's going to have resonance structures when we're done. That's something I started to talk about in class. So let's look at this more carefully. S has 6 valence electrons, and each O has 6. That's another 18. So the count is 24. S is the central atom. And what I'm going to do is I'm going to put dots around the S and the O, enough dots being valence electrons, that everybody has 8. Now when I count, I should actually count that there's 8 here, 2, 4, 6, 8 on the bottom O, another 8 here. That's 24 plus 2 makes 26. So 26 is 2 electrons too many, because I'm supposed to only have 24 to work with. So what do? We talked about in any situation where we have too many electrons in our picture, creating a double bond as a first try. So let's just say I put a double bond here. You could see this O right here now has 10 valence electrons on it. So what I'm going to do is cross 2 of them off. And this S here has 2 valence electrons on it, so I'm going to cross 2 of them off. And that means when I made a double bond, I added 2 electrons, but I lost 4. So my count should drop by a net of 2. And when I count my total, I should have 8 here, 8 here, and 8 here. You can count each pair, and you'll get the same answer, and you have 24 valence electrons. So this picture is now correct. So this is the answer, but it's not actually a complete answer. The complete answer, as I was talking about in class today, is for you to draw all the possibilities, meaning I could have made that double bond in any of those 3 positions. And as much as it can be a pain to do this, you have to do it, because the real answer is actually an average of the 3, and we cannot draw an average. So we draw all 3 with a double arrow. Okay, you don't have to notice in these last 2 pictures, I did not draw dots. So I didn't draw the dots on the O. You don't have to draw dots on pictures, even on the first picture, really. They're understood to be there, but I will require you to draw them because we need to practice and make sure we're counting and making sure our picture is correct. So let's just look at the last problem. It actually is SO3, but it's SO3 minus 2, so it's not sulfur trioxide, it's a sulfite ion. So when I add my count, and I had 6 and 18 like I had before, which was 24, I have to add 2 more. So now my count is 26. So I'm going to put the S in the middle, the 3 O's around it. I'm going to give everybody 8 valence electrons. And as I did in the last picture, I'm going to count and hope that my answer is 26, because if it is, I'm done. Of course, in the last problem I counted, my number was a 24, not a 26, so I had a lot of problems, and I had to make that double bond. But in this problem, I count and I get 8 here, 8 here, 8 here. That's 24, and 2 more make 26. And hopefully you realize that this picture is not complete, not because I have a double bond or resonance, but I have to put this bracket and the charge. Otherwise, it will look like I'm trying to draw the same thing I do in the last problem, SO3. But I'm not drawing SO3, I'm drawing SO3 minus 2. It has 2 more electrons, and I need to indicate that in my final answer. Okay, I hope this helped everybody go through the homework. I'll certainly take questions in class, but I wanted you to have access to this review of the homework. Thank you.